So we saw, in last few classes, we saw that how to find out the resultant of the, how to find out the resultant of the movement, how to find out the movement at one point, at arbitrary point about one, and we also try to find out, the equivalent system, equivalent force and couple system for the given configuration of the. Now, if you see that, let's say uh, when we have the system of forces which are acting on a body, we are able to find out the result. But where it will act? So it will act mass, the 3D object, and it will act at the centroid of the area. If you talk about the movement, the resultant of the movement, in that case, what you really have to do, since movement gives you rotation effect, you will have to find out the corresponding moment of area about this given axis. How the important, like centroid of a given object or the body, as well as the moment of inertia of a given body about an axis, is very, very important from the point of view of linear study. All right. So let us discuss about how to find out the centroid. First of all, resultant of forces. So let us say R X at centroid of the right. So try to, there is an importance of finding out the centroid of mass, centroid of volume, resultant of X about and okay, that we need to find out the moment of or okay, which is tend to either move, or so this one is tend to give translatory motion, this one will tends to move rotating motion. So this is the important, and this is the next topic. And we also saw that any system consists of force and movement can be replaced by an equivalent provided collinear right T the will concentric, not concentric, concentric or well. So these are or how we find, and here also the concept of so let's try to understand how to find out the centroid and body. First of all, let us say if you have to find out the centroid of line element. So basically, if you have to find out, let's say your x, this is your y, and if you have to find out the centroid of this length, which is let's say L, and if its position of this one is R, and if you want to take the position of this one as Y, X, so it means that for a given line element DL, the centroid can be given by centroid X bar will be given by X bar is given by times L over the whole length L, the whole length L. L is the total length. X and Y bar similarly can be Y times here. So after finding out X bar and Y bar from this particular sample, so basically if you try to, then it is really very important that you should relate DL with the quantities associated with the X and Y. You will see that this DL can also be written as plus. So it means that DL can be written as 1 plus 1 plus 1 by so if you have to write this DL in terms of dx, you can write it like this. If you have to write it, you should know the relationship between the relationship of this curve y versus x should be given. Okay, then only you can. Example includes. Let let us say have to find out side of quarter ring, and this ring, and let's assume now if you have to find out uh, things based on, first of all, it means that you will have to find that the centroid of the quarter ring is, and let's assume the thickness of this one is contained as okay. Let the centroid of the quarter ring is, so x bar will be defined as, so first of all, no, okay, s into pl over l, and it means that you try to find first of all bl. All element here, which is, and you can either write, and let's say this is positioned at angle, so, and this is your r, which is given over here. So what will be your x, and what will be your y, and what will be your bl? In polar coordinate, you will see that x is nothing but r cos theta, and y is nothing but r sin theta. This, so, and what will be your dl? R, that this element dl r, so this length. Now if you have to first find out this particular L, L will be given by, here you have r d theta, and theta will be, this will give you, okay. Now you have to find x times dl, x times dl, r square cos theta will be, okay. So r square, and will be sin, that this shows that x bar will be nothing but pi r square by 2, and here pi r by r, l is to pi r square, and sin theta will be, x bar will be r square, and here I r by 2 r. Okay, so x bar in this case that we found was similarly since because of the line element, so it means that there will be your somewhere here x bar which is 2r by 5 and y bar which is 2r by 5. This is how centroid of line element. Now let us discuss about the centroid of area element. Area element. So like line element, area element is also defined as say about okay. So yes, your x bar will be defined as let's assume this is y, this is x, this is your y and this is so with respect to y x into dA x bar will be given by x into divided by total dA over area A and into dA divided by okay. So let's try to, and if it is a discrete problem, then again you consider let us say so first find out A2 and so your whole thing will be divided. Part of this one is given by 1, this one is similarly you will be having y bar 1, y bar 2, y bar 3. And area of this one is A1, area of this one is A2, area of this one is A3. So in discrete sense, the of this particular point x bar will be given by x bar I AI divided by I is similarly you can write y1 which is given by I equal to minus 3 yi bar I equal to 1. How you write when you have to find out the centroid of some two. So find out the centroid of and these are the so let us again take R over we can say that d theta r into d theta. Elemental area P is given by r into d theta into d. Okay. We are taking it in terms of Cartesian coordinate. dA will be dA coordinate. So now and here your r is varying from r1 to. So you have to find out x1. Let's say the position of this x, the position of this. So first find out total dA. Find out total dA. R is varying from r1 to r2. Now then you find out this particular quantity. This will be given by r cos theta. Component is nothing but r cos. So again, and dr is equal to 2 from sin theta by root 2. So this theta will become equals to 1 and this one will become r2, right? So if you divide these two, then r square is this will cube. So it means that your x bar will be given by, and this particular that your x bar will be given by 2 by 3 pi r cube minus r1 cube divided by pi minus r1 square. Okay, you get pi bar which is pi r2 cube minus r1 cube divided by. This is how you try to find out centroid of A. Now what remains is the centroid of volume. Let's try to discuss about the centroid of volume. Of volume. So similar to area and x, this is y. Okay. Um, and this is your dv, and the position of this one from x square plus y square, right? Position of this one back to third of the volume. If you have to find out when volume, let's say p, x, y, and z. When you say x, it means that the position of the x direction, point along y direction is y, along z direction, along z direction is z. Try to define the centroid of divided by y bar x y dv about then this dv, that bar is z dv. All integrations are done. Now let's try to solve one problem. Sense of this one. So the position of this with respect to x, position of this with respect to y. Now you try to find out the center. Find out the centroid. Okay, this is a cylinder with, and this is your, this is your O, this is your Y. Now, if I have to take an element over here, yes, and with an angle theta, I'll just try to amplify this part. So let's take when at a distance r, Now you have to take this at a distance such that its remains. That means that volume of this particular r d theta at a distance r, and this is your dr. Okay, the total volume in this by volume will be given by. Now, what is the component of x again here will be called r, y will be called r sine, will be called as while you are computing your quantity over the total volume thing. So, how you will do? So, all total volume V will be PV, which is nothing but you know, so you will take from 0 to h, r from 0 and you will take and this 0 to pi by 2. What is your component? R d theta dr. In this case, you will see that r square by 2 went from 0 to pi by 2, z went from 0 to h, I square by 2 r. So basically pi by 2 into h into r square by 2, that is nothing but 1 pi r square. H is your volume. Now if you have to compute x bar, so it means that you require this particular portion times dv by r cos theta into 0 to h, 0 to r, h, r. What will be your x bar? Total volume is this. So x bar pi by 2, pi by 2 h r square by 2 4 X bar in this case will be given by 4 by 3 pi. That along this direction, you will have, and similarly, you can, because of the symmetry, find y bar also. So, bar is equal to, because of symmetry, bar. Just look at the condition. How you find out your centroid for curve, for area and volume, and the whole force is, and the resultant of the force end of the centroid.